All right, today we're going to tackle something that can feel a little tricky in precalculus. We're talking about how to solve for a variable when it's like trapped inside a trig function, like sine or cosine.
So how do you solve for x when it's trapped like that? It's a classic precalculus puzzle, right? Your x is stuck inside and you got to get it out. And yeah, it might look a little intimidating at first, but here's the good news. There's a solid method, a strategy we can use every single time to crack it. Okay, so what's our goal here? It's to find all the possible values for x that make the equation true. Now, this isn't like your simple x plus 2 equals 4 where there's just one answer. Nope, trig equations are a whole different beast. See, these functions are cyclical. They just repeat over and over and over again forever. And because of that, we often end up with multiple, sometimes even infinite solutions. Our job is to find every last one of them. And to do that, we have this awesome 4-step solution key. It's like our secret weapon. Step 1, isolate the trig function. Step 2, find the reference angle. Step 3, figure out all the quadrants where our answer could be hiding. And finally, step 4, write the general solution to catch all the possibilities.
All right, let's put this key to work. Time for our first solve. So let's start with a real classic. Sine of x equals 1/2. Now, just to keep things simple for this first go-around, we're only going to look for answers on one single trip around the unit circle, from 0 to 2 pi.
Okay, step 1 and 2. First is the function isolated. Yep, sine of x is already by itself, so that's done. So on to step 2, find the reference angle. We just have to ask ourselves, the sine of what angle equals 1/2? And if you've got your unit circle handy or just have it memorized, you know that angle is pi over 6. That's our reference. Now for step 3, this is really where the magic happens and we start to see why there's more than one answer. That 1/2, it's a positive number, right? So we have to think, where is sine positive? On the unit circle, that happens in 2 spots, quadrant 1 and quadrant 2. So all we have to do is take our reference angle, pi over 6, and place it in both of those quadrants. In quadrant I, it's easy. The angle is the reference angle, so x is pi over 6. But in quadrant 2, we have to do a quick calculation. It's pi minus our reference angle, which gives us 5 pi over 6. And boom, just like that, we've got our 2 solutions. Okay, not too bad, right? We've got the basics down. So now let's level up a bit. We're going to talk about general solutions and what to do when you have to factor. This idea of a general solution is super powerful. It's basically a formula that describes every single possible solution, out to infinity. It works by saying, okay, here are your starting answers, and now just add any number of full rotations. That little plus 2 pi n you see, that's the part that catches everything, where n can be any integer, positive or negative. Let's try it out. If we need to find all solutions to cos x equals -1, well, where does that happen? There's only one spot on the unit circle where cosine is -1, and that's at pi. And since we know the cosine function repeats every 2 pi, our general solution is just x equals pi plus 2 pi n. Simple as that. All right, now things get really interesting. What happens when you have more than one trig function in the equation? Like this one, this example right here. This is going to show us the single biggest, most common mistake that students make. Seriously. I'm not kidding. This is the big one. Learning how to avoid this common trap is what separates the people who get partial credit from the ones who ace the problem. So look at this. The temptation, and I mean it's a strong temptation, is to just divide both sides by cos x. It looks so clean. But don't do it. The moment you do that, you're assuming cos x can't be 0, and you literally just throw solutions in the trash. The pro move is to get everything to one side, set it to 0, and then factor. You see? You pull out the common cos x. This way, you preserve every single possible solution. And check this out. Now that it's factored, we can set each piece equal to 0. This turns one complicated problem into 2 easy ones. Cos x equals 0 gives us 2 answers, pi over 2 and 3 pi over 2. And 2 sine x minus 1 equals 0? Well, that's just sine x equals 1/2, which we already solved. That gives us pi over 6 and 5 pi over 6. So by factoring instead of dividing, we found all 4 solutions.
So, So, okay, we can solve these equations. But why? Why does any of this actually matter? Let's talk about how this stuff shows up in the real world.
Think about this. Coastal engineers use these exact kinds of equations to predict high and low tides. I mean, the rhythm of the ocean, the way the water rises and falls, that's a wave, a sinusoidal pattern. And being able to solve for when the tide will be at a certain height is absolutely critical for shipping schedules, for coastal construction, even for planning against floods. And that really gets you thinking, doesn't it? What other waves and cycles are all around us? Because this math, it's not just for tides. It's for sound waves, it's for the AC electricity in your house, it's for all kinds of oscillations in physics and engineering. This is the math that describes the rhythm of the world. So what other cycles can you think of that are governed by these same equations?